All right, this is Unit 9, Section 9.1. We're going to start off with an introduction to quadratic graphs. So in this unit, we are going to step away from factoring. We'll definitely come back to it next unit. But to start looking at why we factor and what do those values mean and what process does it help us as far as our quadratics. And so today we'll kind of do an introduction. So we want to be able to identify some key characteristics of quadratics and identify mainly the vertex and axis of symmetry. So these are going to be some key characteristics of our graphs. I wanted to also point out, and I don't typically draw our attention to the standards here, but this is a unit that has tons of standards in it, meaning as we get ready for the Kansas Math Assessment or the ACT, this is going to be a really important unit that will definitely have questions that always draw from this idea. And so kind of keep that in mind that if I would say the first semester was trigonometry was a really big idea that we're going to carry on with that right triangle Pythagorean theorem and trig, SOHCAHTOA. This year or this semester, I'm going to say it's going to be our quadratics, our factoring, our graphing. Those are going to be our main big ideas this semester. And so when we look at 9.1, we're just going to start looking at what is the graph of a quadratic. So when we graph it, a quadratic equation creates a U shape called a parabola. Okay, and we're going to use Desmos.com to kind of get a sketch of this. And so we have a couple types of parabolas. And so when we look at this, I don't need an incognito window. Un momento. Okay. So I'm going to go to Desmos.com. Follow along with me here. And it says let's graph. And we want to sketch y equals x, and then I'm going to use squared plus 2x minus 5. All right, so here's our first graph that we're kind of sketching here. So it goes down, here's our axis at 0, 0, it's going down, it's crossing here, it turns here, it crosses the y-axis here, and then the x-axis again here. So again, this is just a sketch, but it has this idea of we are going down and then turning and coming back up. Making sure, I know I'm a little wiggly, but this is a U-shaped curve, and so it's not pointy. So it's not a V. That's not what we're drawing here. It's a U-shaped graph with a curve here. The second one, okay, so now I'm going to graph another one that says this is negative x squared plus 3x plus 7. Okay, so now I have this graph, and I need to make mine a little bit bigger so I can kind of see where it's turning. All right, so again, you can grab this, we can zoom in and out. And so this one, now it's going up, 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 crossing the y-axis, turning and coming back down. Okay, so this graph looks something like this, where it's going up, crossing, crossing, turning, coming back down. And so the two types of parabolas we can have here are ones that open up. Do you see how I kind of like the U here? Or the ones that open down. And then I do like the N, like this. And so we have two types of parabolas. And one of the basic ways that we can tell the difference between these two is by looking at the equation. We can tell whether it opens up or down. And it's based on this number out in front. So in this case, if I look at my value here, I have an A equals 1. Okay, A equals 1 was opening up. In this case, I have a negative A. So I have A equals a negative 1. And that told me to open down. This is our basic characteristic here. If A is positive, so any positive number out front of x squared, then this is going to be a parabola that opens up. So it opens up like this. If A is negative, then our parabola is going to open down like a frown, like this. And so as we start looking at the characteristics, A is going to be an important characteristic that's going to tell us kind of the shape and direction of ours. And then we'll start looking at everything else kind of put together. So let's just determine whether the parabola opens up or down. So again, I'm going to go ahead and box in my A values here, and it has to be in front of x squared, okay? And even though there's not one there, I'm going to kind of draw in my 1, just like a negative is a negative 1. And once I've identified my A, so if A equals 3 here, that's positive, so it's going to open up. A here equals negative 2, negative, going to open down. Negative 1 for our A value. This is going to open, whoo, I almost got myself there. We're going to open down, negative down. And A equals just a positive 1 will be up there. All right, so A is going to be one of those characteristics that tells us it's kind of leading us towards what our graph looks like. The second part is this idea of an axis of symmetry. So symmetry means that we have something that's going to match when we fold it across a line. And so as we look at our U graphs, whether it opens up or down, there's this imaginary line down the middle where we have pieces over here that fold over and match over here. And no matter where I do that, it would fold over. The only part that doesn't is the value that is on our axis of symmetry here. And this point doesn't have anywhere to go. It's like if you put your nose on a mirror, it can't reflect it because your nose is on it. That's the same thing here. If I'm away from the line of axis of symmetry, it will go across. If I'm on it, it stays in the exact same spot. So this is the vertical line, so going up and down, that divides the parabola into 2 equal parts. And we could almost say 2 symmetric parts. The formula to find the axis of symmetry is, and I abbreviate it to AOS, is x equals, because it's an equation of a line, opposite of b over 2a. So A already tells us if it opens up or down. Now we're bringing in B with A together to tell us this axis of symmetry. And so if we use this formula, x equals opposite of B over 2A, for each one of these. So I'm going to use the same formula each time. So I can clone it, going to use it here, clone it, going to use it here. And we can fill in those values. So in this case, we have an A that's 1, and we have a B that's 3. So I'm going to sub in opposite of B is 3. So negative 3 over 2 times 1. And so when I put this in my calculator, I get x equals negative 3 over 2. All right, so we'll start talking about what this line looks like on the graph, but right now we need to know how to calculate it. On number 2, we're going to have x equals, okay, we have my A here, my B here. Notice I'm boxing in the sign with it. Opposite of B. Okay, so what's the opposite of negative 3? Is positive 3 over 2 times A, which is 2. And I simplify. Notice that I'm keeping this as a fraction. 2 times 2, I get 4 here. Okay, I'm just leaving it. I'm not putting it to the decimal. I'm not rounding it. And on number 3, we have x equals, okay, we have our A value here, our B value here. So the opposite of positive 4 is negative 4, divided by 2 times 2 here. Okay, so negative 4 divided by 4, that's negative 1. And so what that tells us, okay, since this one is an integer, if I start at 0, 0, and now I move that over to negative 1, I don't know where it is as far as height, but I do know that this is my axis of symmetry, that there's some imaginary line that I know that somewhere on here is where my curve turns. And so that's where we can start to, again, create this graph, putting all these pieces together. Okay, the other main characteristic goes along with the axis of symmetry. This is our vertex, and this is a major characteristic. Okay, this is where the parabola turns. So every parabola has a place where it turns from going up to going back down, or from going down to going then back up. So each one of these parabolas is going to have a vertex. And just like we did before, okay, it's going to fall on, I'm going to go ahead and push that over there. It's going to fall on our axis of symmetry. So they're definitely related here. Man, I keep missing it. But this is either the lowest point here, or it is I'm going to have to switch those. Okay, it's either going to be the lowest point, or I'm going to say the highest point. I have a typo there. All right, so as we're looking at this, it says when the vertex is at the lowest point, okay, this is going to be called the minimum. And this is because it opens up, there's a low spot in the curve. It goes all the way down and then back up. This is the lowest that it gets, a minimum. When the vertex is the highest point, like this is called a maximum. And it opens down because it's going to be going up, 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 up to the very tip top vertex and then back down. This is going to be the maximum that our graph reaches. And so the vertex is on this axis of symmetry. So when we want to find the vertex algebraically, we first need to find an x value. So that'll give us x. Okay. Then we need to substitute our x value back into the equation to find the y value. This will give us our x and y coordinates here. Write the vertex as an ordered pair. So I don't want two little equations. I don't want it to be x equals some number and y equals some number. We want it written as the coordinates. X comes from the axis of symmetry, y comes from plugging it in. So again, our three main characteristics that we're talking about today are the opening, up or down, the axis of symmetry, and the vertex. So let's put this together, looking at a couple examples. All right, so A tells us whether it opens up or down. So on here I have a 1 for A, so this opens up. Okay, I can go through and do all of this for each one because it's very much a pattern. If it opens up, this has a low point, so it's going to be a minimum. Okay? If I want to do those two pieces on every single one of these, I can. I can say, okay, here now I have a -1, so it opens down, making it an upper value, a maximum, because it's going all the way up and then back down. If I look at the next one, okay, so this is now where I have an A value that's 3. Okay, so that's going to be opening up, minimum. Always those go together. Positive opens up, minimum. Negative opens down, maximum. Negative opens down, maximum. Oh, okay. So again, on those 6 examples, I just went through and did those first 2 characteristics. The next one says find the axis of symmetry. So that is x equals opposite of b over 2a. So I'm going to plug into opposite of b, so positive 8. The opposite of that would be -8, divided by 2 times my a value, which is 1. So -8 divided by 2 is -4. So my axis of symmetry is x equals -4. Don't forget the x equals. Don't forget. Axis of symmetry is x equals a number. Okay? don't forget, vertex is an ordered pair, some x, some y. So in this case, the vertex, we already know it's going to be the same x value of our axis of symmetry. But the new part that we need to do is plug it back in to find the y value. So in my calculator, I'm going to do substitution, plugging in -4. Anywhere I have an x, I just put that in parentheses. And then I can type that into my calculator. Okay, so let me make sure we have a calculator pulled up here. Yes, I can leave that. So I'm just using the one that's on my resource page so that you can see what I'm doing here. Okay, so now it says to do parentheses -4 squared plus 8 times -4 plus 15. All right, so my y value is going to be -1. And so that will finish out this piece. I have my x from the axis of symmetry. I have my y from plugging it in. All right, on number 2. Now we have an axis of symmetry, so x equals opposite of b over 2a. So x equals opposite of +10 is -10. So I'm just changing the sign over 2 times -1. All right, so -10 divided by -2 is 5. So my axis of symmetry is x equals 5. I immediately pull it down because it's part of my vertex. Then I want to plug that in to my y value. I have negative. Now I'm plugging in my x, putting that in parentheses. The parentheses matter. Put them in parentheses. So the only thing we're changing is x. That negative comes down, parentheses, replace x. +10, parentheses, replace x. So that we can go into our calculator and find this. Okay, so now I have too big of a screen here. So we will take negative, that's not what I want, negative, parentheses, 5 squared plus 10, parentheses 5 minus 23. And so the y value I get here is 2. All right, so I have my x, now I have my y. So again, this is giving us a really good idea of what this looks like on the graph. Right now we're finding them algebraically, and then the next day we'll start putting them on the graph to like actually plot and get an idea of this picture. All right, we have number 3 opens up as a minimum, and then we need to find the axis of symmetry, opposite of b over 2a. So the opposite of -12 is +12. And then 2, replace a with 3. 12 divided by 6 is 2. So my axis of symmetry is x equals 2. All right, for my vertex, I'm going to plug in 2. So wherever I see an x, put parentheses, and 2 gets replaced into it. I see an x, replace it, parentheses there, plus 5. All right, so on my calculator, I can go ahead and substitute this in. 2 squared minus 12 times 2 plus 5. And I get -7 for my y value. So that means my vertex, the x-coordinate is 2, and the y-coordinate is -7. On number 4, axis of symmetry. X equals opposite of b over 2a. Opposite of +8 is -8. 2 times a value is 4. So -8 divided by 8 is -1. So my axis of symmetry is -1. X equals -1. And then for y, we're going to plug in 4 times -1 squared plus 8 times -1 minus 1. Got a lot of minus 1s going on here. All right, 4 parentheses. Don't forget parentheses. I'm just plugging in here, -1, and I get y is -5. All right, so I have my x value, -1. I have my y value at -5. All right, on number 4. We already know this one opens down and a maximum. So now we have x equals opposite of b over 2a to find the axis of symmetry. So opposite of -24 is +24. And then 2 times a is -3. So 24 divided by -6 is -4. Okay, so there is, that looks kind of like a not equal to, x equals -4. And then I'm going to plug into y. -3, replace x, don't forget parentheses, and -42. All right, to my calculator. Just kind of moving it back and forth here. -24, -4, -42. All right, so now we get y equals 6. All right, so our vertex, x coordinate, comes from the axis of symmetry. Y coordinate is 6. On the last one, we have that this opens down as a maximum, and then we can find the axis of symmetry, opposite of b over 2a. Okay, so opposite of b, opposite of +4 is -4. To a is -1. So -4 divided by -2 is +2. And then plug in negative, replace x, parentheses. That's where we're going to pull in our 2. +4, replace x with parentheses, and plug in 2. So I have -2 squared plus 4 times 2. And we get our y value is 4. Let your calculator do the work, but be careful on how you are entering it in. Make sure your parentheses are in the correct spot. All right, so today we want to be able to find whether it opens up or down, and accordingly goes with a maximum or minimum. So down is always maximum, up is always minimum. Axis of symmetry is opposite of b over 2a. And then the vertex is taking our axis of symmetry and plugging that value in to find the y coordinate. Let me know if you have any questions as we get into this practice.